Morning, guys. We're going to continue with the topic, overcoming friction. This is the last one. This is the same topic that we have been seeing, that is overcoming friction, but now I did a change. As you can see, now we're working on what we know as an inclined plane. Okay. What is going to be the difference here? That's what we're gonna see in this problem. So, student attaches a rope to a 25-kilogram box of books. Well, he pulls on a ramp which is inclined 30 degrees to the horizontal. He pulls with a force of 120 Newton at an angle of 35 degrees with the floor. The coefficient of kinetic friction between the box and the sidewalk is 0.5. Find the acceleration of the box. So, as you can see here, the only difference that I did is that I added the 30 degrees of inclination. That means that we're going to be doing a few changes. The most important change that we need to consider, I'm going to give it to you in a note. It's that the main difference that we're going to have is going to be the weight. Okay? The weight is the one that is going to change. Now, another thing that is going to change is the free body diagram. We used to have totally straight free body diagrams, but now, with this type of problems, our free body diagrams will also be inclined. So let's take a look. Well, as I told you, the main difference that we're going to have, it's going to be the weight. Now, remember that to calculate the components, we usually say that a component in x has cosine as a trigonometric function. But here, for the weight, only for inclined plane, it's going to be the x component will be using sine, and the y component of the weight will be using cosine. Now, let's take a look. What are the givens in this problem? Okay, we have 25 kilograms, a mass of 25 kilograms. This angle here is the most important, that's why I already highlighted it. Now let's take a look. The force is 120 Newton, and the angle of the force is 35 newtons, okay, to the floor. These 35 newtons are measured to the floor. Here is the floor, okay. The coefficient of kinetic friction is 0.5 and are asking us to find acceleration. Now let's take a look. We're gonna be doing the same that we used to. The free body diagram is going to be like the step 0, okay. The step 0 is the free body diagram because we need it a lot. Now, instead of drawing like we used to, let's take a look here. We have a force of 120 Newton. We have a surface, therefore we have a normal. This normal is always located, this is the normal force, and this normal force is always located at 90 degrees from the surface, okay? That is one condition that must be accomplished. Now, remember that my force is going to have components. Force in x and force in y. But there is another thing that I haven't mentioned, and it's the weight. The weight is located in the middle, in the center of my mass, which is here, okay, more or less. And it's always coming downward, straight downward, not like the normal that it's located according to the surface. No, my weight is always coming downward. Now, here is where the magic occurs. If I have a Cartesian plane, okay, imagine that I have a Cartesian plane. I'm just gonna do it as a dot line, okay, something like this. Remember that the normal goes over the y-axis, so this is basically my y-axis. As you can see, I did a Cartesian plane where this is x and this is y, okay. This is the negative side of x, this is the positive side of y. X positive, negative y. Now, take a look here. This angle here of 30, it's gonna be located here in my Cartesian plane. And that is why, because this angle is according to the vertical, that is why my weight here, horizontal, is gonna be taking sine and cosine for the y component. So, in the first step, what I did, as you can see, it's not a general kind of thing. So now I'm gonna be drawing it by using, of course, a ruler. Okay. So my main axis okay, so I did my Cartesian plane, and now I will include all my forces. Now I know that my force of 120 Newton is divided into its components, okay, but my force of 120 Newton look like this. Now this force also has components. In X and in Y. I don't know the components yet, but I know they are located there. Now my normal, it's over the y-axis. That's my normal. And as I already told you before, my weight is always straight downward, okay? Oh my god, sorry, this is 35 degrees. Now here it's straight downward. I have here my weight. And here I have my angle of my ramp, okay, of 30 degrees. Now, how is my weight divided into its components? Okay, as I already told you, my x component will be using sine and my y component will be using cosine. So this should look more like this. Because this line is parallel to my x-axis, this is going to be wx. And because this line comes over the y-axis, this is going to be called wy. And as you can see, my component y here, it's touching my angle, so that's why here I use cosine, because it's touching my angle. And my x component, which is in front of my angle, therefore it's going to be using sine. That is why we use these components. Now, if you don't want to do all this process, just memorize. Remember, memorize that the weight in X is going to be using sine, and for Y it's going to be using cosine, but only for exercises that are on a ramp. Now, the next process is a process that you already know so well, where my first step is to calculate the components. In my first step, I calculate the components, and it's going to be fx and fy. 120 cosine of 35 and 120 sine of 35. When you do this in your calculator, you will get 98.3 and 68.83 Newton to the right and upward. In my second step, I will be calculating the weight, okay? And the weight, as you know, it's mass times gravity. So my weight is 25 kilograms, negative 9.81. Okay, 245.25 Newton downward. Now, because my weight has an angle, it's going to have components. So now is the time for us to use the weight formulas, Wx and Wy. So this is going to be the same value for for W, okay? This is W, okay, 245.25. For X, I'm going to be using sine of my angle. What angle? Of my ramp, okay? And this one, also of my ramp. Get this on your calculator. Okay, I got 122.63 and 212.39. Now, remember that we always consider the direction. So my W in X, as you can see, it's coming to the left. So it's going to be to the left or negative, okay? And in Y, as you can see, it's coming downward. So you have to include the symbols, okay? Now, what happens after the weight? Okay. So as you can see, I already got all my components of my force and of my weight. Now what I'm going to do is I will update my free body diagram and I will continue in a different page. So as you can see right now, I'm updating my free body diagram. I will just draw the same that I had to, okay? Y-axis and x-axis, and I will include all my forces. Why am I doing this again? Because it helps me to visualize better what's going on in the problem. Remember, a free body diagram helps us to visualize all the forces that are acting on my mass, the mass that I care about. So, I have here the normal, okay? I also have my y component for the force, that is Fy, and I also have my x component of the force, that is Fx, okay? I know that I have values already. Fx is 98 and Fy is 68. Now, I also have my weight in x and my weight in y. That's what I'm going to include right now. Now, my Wx comes to the left. And my WY comes downward. So this is the free body diagram already updated. I already know my forces, Y and X and Y. That means that right now I'm going to look for the normal. That is going to be my next step. But you already knew about it because that was the next step to follow. Now, let's take a look. In the third step, I need to get the normal. In order to get the normal, I need to add the forces in y-axis. So we say the sum of the forces in y equals 0. Why in 0? Because the object is moving only over the surface. Okay? It's moving only on the surface. It's not jumping. Okay? It's not moving vertically. So we say normal because it's going up plus Fy because also it's going up minus Wy, not W, okay, Wy equals 0. So here we're not going to consider the weight, but the weights component in Y. So that's why we are getting this. Normal, we isolate for this, so Wy is going to be positive and Fy is going to be negative. So the normal here is going to be Wy, which is 212.39 Newton, minus Fy, that is 68.83 Newton, and my normal is 212.39 minus 68.83, 143.56 Newton. What comes after getting the normal? My next step, that is friction. Now I need to get my friction. Okay, here I didn't consider in the initial free body diagram because now is where I'm going to consider my object. The boy is pulling the box. The boy is pulling to the right. Okay, he is pulling to the right. So my object is going to move in this way. That means that my friction goes always opposite to it. So this is my friction. The friction is opposite to the object's motion. So in my free body diagram, now I will include the friction. So my friction now, I'm gonna do it in a different color. Let's see if I have a different color. Interesting. Okay, I will use this one. So my friction, as you already saw, comes in this direction. Okay, now this friction is kinetic. That's how you locate the friction, because my object is moving to the right, so my friction comes in opposite. Okay, how do you get the friction? Well, kinetic friction equals mu k times the normal. Mu k is 0.5, and the normal that we just got, that is 143.56 Newton. This gives me, Fk gives me 71.78 Newton. And in my last step, take a look there, the same amount of steps, the exercise, the topic before, okay? But we have been doing a few changes each time. So right now, we're gonna look for acceleration. So we say the sum of the forces in x equals mass times acceleration. Acceleration equals the sum of the forces in x divided by the mass. Acceleration equals, okay, what do I have in x? In the positive side of x, I have fx. Adding, okay, because it's positive. Fx minus wx, because it's going to the left. And also fk, it's going to the left, so it's going to be negative. All this divided by the mass. So my acceleration will be Fx, that is 98.3 Newton, minus Wx, that is 122.63 Newton, minus Fk, that is 71.78 Newton, divided by the mass. The mass, that is 25 kilograms. So my acceleration is going to be negative, and I'm going to explain you what that means. Okay? So my acceleration is, how are we going to do it? Okay, 98.3 minus 122.63 minus 71.78. Okay, the answer that we got, we're going to divide by 25. Negative 3.84. Negative 3.84 meters over second square. Now, what does it mean? Because my acceleration is negative, we can conclude that this boy is incapable to pull the box of books. Okay, he is incapable to move it. That's why this mass, instead of going to the right, is going to be moving. Actually, it's going to be moving downward to the left. That's why we got an acceleration of 3.8. So what does he have to do in order to make the acceleration positive and actually move the box? Well, probably he needs help. Okay, someone may be pushing the box from here, or also he needs to pull harder. That means increase the force. But that's not part of today's topic. This is the acceleration that we got. That means that our box will move to the left instead of to the right. So the boy is incapable to pull the box of books. That is a conclusion that you can write about it. So this is it, guys. Thank you.